Open Agent Architecture, Automated Office Demonstration, copyright 1997 by SRI International. As the world becomes more network reliant, we will need new architectures and paradigms for building computer applications. In this demonstration of the Open Agent Architecture, a dynamic community of distributed software agents cooperate with each other in a flexible manner. In the automated office application domain, a user who is traveling can reach back and access his calendar, database, and email applications, all of which are commercial systems running on different machines back at work. In addition, artificial intelligence technologies such as speech recognition, natural language, or text-to-speech may be added to the agent community. The user interface agent, which you are looking at now, runs on the user's laptop or PDA, and he or she may use a telephone in order to access remote speech recognition services. All of these agents are coordinated by a facilitator agent who knows the capabilities of each. The user interface is structured using a room-based metaphor. By clicking on various items in the room, the user can interact directly with agents controlling applications on remote machines. Here I'll enter an appointment into my calendar, doing an Open Agent Architecture demo. I'll make this 1 hour. This simple interaction style could also be programmed using other distributed technologies available today, such as Corba or Telescript. However, now we shall begin to show the unique flexibility that the Open Agent Architecture brings to building distributed systems. In this lower field, the user may make any request that can be handled by the entire community of distributed agents. As new agents come and go at runtime, what the user can say or do literally changes. As a simple example, I'll ask a database-style question. Who is my manager? When I press the Do It button, the facilitator agent rapidly coordinates interactions among the user interface, natural language, and database agents. Speech recognition may also be available. What are my appointments? And here we see the appointment I entered earlier, Open Agent Architecture demo. We've seen that agents can be used to transparently access numerous remote services, either in a directed or delegated manner. Another property all agents possess is the ability to monitor or keep track of information on behalf of the user. In this example, incoming email messages of a certain type are very important. When mail arrives for me about security, notify me immediately. And as I send out this request, a trigger or monitor will be added to the correct agent or agents in the network. Now I will send myself some email, which should match this request. I'll give it a title of Security Alert. And the message will say, Warning, intruder detected. The email agent will now send this message out through the Unix mail system, and eventually it will arrive back into my mailbox. Hello, Adam Chire.
Adam Chire, you have an important message. Enter your password, followed by the number sign, and I will read it to you. If you are not Adam Chire, enter 0 followed by the number sign. Subject security alert from Adam Chire. Warning, intruder detected.
Let's look at what happened and why this is interesting. At the user interface agent, I clicked on a microphone button requesting speech recognition. Audio arriving from the telephone agent was routed to the speech agent who listened to the words I was saying and returned some text representing these words. As I pressed the Do It button, these English words were sent to the facilitator, who routed them to the natural language agent for translation into the interagent communication language. The NL agent collects its vocabulary dynamically from the domain agents and returns something in the form when, a condition, and an action. Here the condition was when mail arrives for Adam Chyer about security, so this could be routed to the email agent to install the trigger, watching incoming messages. As mail arrives from the outside world, the trigger fires. Let me point out that commercial mail systems today can have rules such as when mail arrives, delete it, or forward it, or archive it. However, the actions for these rules must be known in advance. In the OpenAgent architecture, actions for triggers may be any request solvable by the entire set of dynamic agents. Here the request was for notification, so this could be handled by an agent specializing in information transfer across media. The notify agent first needs to know where the user is, so it sends this out as a request. Here multiple agents can respond in parallel, so a calendar agent might look up to see if he's in a particular room. A database agent can return a default location of his office. Once the notify agent has determined the user's location, it figures out how to get him the message. In this case, telephone was chosen, so in parallel, requests are sent out for an audio form of the message, for the telephone number for the location, and for the user's password. Here, the text-to-speech agent creates the audio version of the message, and a database agent returns the password and the telephone number for the location. When all of this information is collected, it'll be routed to a telephone agent who will dial, check the user's password with touch tones, and then play the message. What we have seen in this demonstration is a dynamic community of software agents running on different machines, written in different programming languages, interacting, cooperating with each other on behalf of the user to perform requests for him at a high level.